All right. Oh, okay. Okay. Yeah, things are happening. So, yeah, I'm just jamming out. Oh, okay. All right. Okay. So, last time I got matrix multiplication to work, so that was pretty cool. I think what I need to do is I need to focus on addition next. So I need to build the graph for that, and then I need to work on. Okay, so I'm gonna rename this. Yeah. Okay, so I want to do addition next. Yeah, no, okay, so I want to add verts. Yeah, I can go ahead and do that. Alright, well, that's pretty solid. Except, I didn't use correct grammar there. Okay. So now I can just say for I just want to add the vertex. And then I guess I just want to create an edge between yeah, so I just need to do add edge between the vertex. Or no. I need to make it between self. Oh man, what should it be? Self. Oh geez, I just realized this is actually wrong. It should be self.vertex. Right? And that should be between the to the molvert. Yeah, okay. Yeah. Wait, actually, why do I do double vertex list? Yeah. Wait, hold on a second. What does vertex list actually get me? It gets me a list of vertex lists. Okay, so I don't need double vertex list. That's a psyop. Okay. Yeah, it doesn't make sense to double vertex list. I could do single vertex list. Oh no, I can't do single vertex list. Yeah, I have to do double vertex. I have to double vertex list. Okay, I see. All right. that should yeah, I should just be able to do vertex list rows, vertex. Oh yeah, I should be able to do that. That should be good. All right. Oh. Okay. Okay. So, what was I doing? I cannot tell what I was supposed to be doing. Self. Okay. Wait, yeah, why do I say rows here? What the heck's up with that? I can do vert list. Okay. Oh. Oh man. So I guess what I actually need is just a matrix graph. Ah. Yeah, because otherwise I have to like... Okay. So I actually need to say dims is okay, so I need to say dums. Okay, and so graph array should also take this, so it should be dim. Yeah, I'm gonna remove insert nodes. And the default will just be to insert the nodes. Unless, oh man. How do I want to do this? So, I want to take an arbitrary thing. Or, yeah, okay. So, I want to be able to define operations, and I want to draw the graph of those operations with matrices. So, I guess maybe I need to do something like, let me think here. So how am I gonna like outline these operations? Ah, okay. So I guess maybe I could have like yeah, I guess maybe I could just like call it like I have A. It's a GMAT, and then B is another GMAT, and then I can say like A dot mul B dot add B dot mul C dot something like this, right? So I set up a chain. And then I guess the output of this is like an operation or something. And an operation uh, is like just a computation graph. So something like that, right? I don't know. Yeah, I guess I could try something like that. I think I need to refactor a lot though, which is okay because I literally just started. So yeah. Okay. So let's think about our graph array, right? Our graph array is like essentially just, and you know what? Let's actually simplify this. And so instead of having a graph array, let's just have a graph matrix. So let's not even think, yeah, because it's, I mean, fundamentally vectors are literally just matrices. They're just, 1 by n matrices or n by 1 matrices, right? So yeah. So I mean, I'll just think about this in terms of just matrices. So I guess I'll just have a thing called, graph matrix. And then I guess maybe I want to have like a computation graph or something. But for now, what I'll do is okay, so I want to have dimensions. I want to have dimensions and okay, so yeah. Hmm. Okay, so I'll bring this back up. Yeah, so how do I actually like compute this? Okay, yeah. I guess what I can have is graph matrices, and then I can so graph matrices will literally just be like matrices, and they have dimensions, but they don't actually have any data in them, right? All they are is like a set of nodes. And then when we actually want to do the op, then we would say like op dot like perform or something. And then we would actually plug in A, B, C, right? Um, yeah, I think something like that could probably work. Um, okay, yeah, no, okay. Sorry, A prime, B prime, and C prime. So like A prime, B prime, and C prime are data. How? Why does it not look like data? Did I actually just write like Darat or something? Or Datat? Like, what did I write? Alright, data. So that's actual data that's done. And like, that's just like filled in for A, B, and C or whatever. Um that, or we just define what A, B, and C are ahead of time. I don't really know. Or we build up the computation graph and then plug those in, as we know them. I suppose it's also possible. That's kind of like a streaming approach or something, Like we compute as much of the function as we can all at a certain time, something like that. But yeah, okay, yeah, I'll try that, I guess. So we have a dimension, and then let's do a graph, which is a graph, and then we have a dimension. And then we actually need to do stuff. So we need to say like um so we add a new thing. Now I do self.vert -1. Okay, so a graph matrix is like literally just a set of variables. Yeah, it's literally just a set of variables, and we're doing manipulations on those variables. Like we're like when we do like .mol or whatever, we're like outlining the actual computations that will be performed, something like that. Um, okay, so yeah, I guess I can do get item. I think that's gonna be like the most interesting thing. Yeah, and I can just say self.dims. I want to do self.verts item. Okay, yeah. Let's say that makes sense. And so I'm just gonna have one thing, which is mole. What is imole? imatmole? What? What are these? What? No way. Wow, that's really cool. Wait, so what is rmatmole and imatmole? Yeah, what is... Oh my god, 3.10? What did I just do? Oh. Wait, what? I can't control F. What's going on? Am I going crazy? Oh. Yeah, I'm just an idiot. Okay. So, yep. imatmole. What is rmatmole? What is rmatmole? What is this? What the heck is rmatmole? I'm gonna go crazy. No, it's... What is it? What is due? Cancel. What? Okay. What is R mole? Oh no. I don't want that. Oh, Geeks for Years looking snazzy. Tell me what R mole is. Oh. Got it. Okay. I understand. Man, that was a doozy. Wait a second. Wait a second. Wait. God damn it, I missed it. Okay, got it. I see. Okay, so I don't want R mole. Right mole means that it's the right object being multiplied by the left object. That's how. Okay, it seems like that's what that's called. Okay, so what I want to do. Yeah, man, I'll try map mole. This sounds kind of interesting. You know, why not? This is the @ operator. It's kind of weird. It's kind of spooky, kooky. Okay, so now here's where it gets interesting. Yeah, so I guess maybe what I want to do is I want to like create new graphs, right? Like I actually want to like copy this graph. Grap. Grop. Okay, yeah. So I guess I just want to like copy the graph or something, right? And so what I want to do is so instead of having yeah, I want to do output.graph.add vertex. Ah, okay. So yeah. In fact, I never want to do that. I want to do Oh, but I want to like merge the two graphs. Okay, how do I do that one? Um yeah. Merge graphs. Graph tool. Graph union. Okay. Okay, so what does graph union do? What is the behavior? Where's the For the union of graph composed of all the edges and vertices without overlap. What does without overlap mean? Huh. I am really confused here. Vertex property map owned by G2, which maps each of its vertices to vertex indices belonging to G1. Which maps each of its vertices to vertex indices belonging to G1. I know. Like, I need to somehow map these two, but I don't know if I can. I gotta take the union, but it seems like when it does the thing, it'll just like do another thing. So I guess what I can do is I can just use like a heuristic method. I can generate like a random integer for each vertex. And then, you know, if the space is sufficiently big enough, then I probably won't have to worry about duplicates. That's one way to go about it, I guess. The other way, which is kind of slow. You know what the best method probably is? It's probably not to, yeah. I guess the best method is just to take all of the matrices, yeah, it's just to use one graph for everything. And I can just assume graph matrix. So I do, yeah, I can just assume that everything is using that same graph. However, okay, yeah, so what I have to do is I have to say like, I have to say that, right? Oh no. And then, okay, so everything on the graph matrix is using the same. So okay, I'm actually going to define a new thing, which is a Python file, which is and I go to matrix. Okay, now I go down here. I'm just gonna delete array. I actually don't think I need this like at all. So what I really want to do is I want to say yeah, I want to say import graph object. Fine, 2 blank lines. Sheesh. Okay, so now I say graph object.graph, right? So I don't actually import. Okay, this is starting to take shape. So I would actually just say graph object.graph. Okay, output vertex list. Okay, so I wouldn't say output vertex list. I would just say output.verts. So we are... Okay, yeah. So I actually don't want that, right? Like output already has all the verts because when I did this, I created all the verts. Alright, so I'm adding it there, and then I'm just creating a dictionary that remembers all of them. And I guess for a reason I don't need that, but I'm just going to keep it because I am weird. And I'm adding a new edge. Yeah, so all graph matrices exist in the same graph, which makes sense, right? Like, they all exist on the same, like, machine or whatever. Or, yeah, they all exist within the same, like, context. So I want to add it just between self. Yeah, and I'm not using r.vertexList. I'm just using r row and call. And r row call will actually get me the actual thing from the graph. Yeah, okay. This makes perfect sense. And then I add it. Yeah, okay, so add these to the molvert. Yeah, I do really wish that I was setting labels for this. So what I can do, I guess, is I can just go ahead and say graph.addVertex. No, not addVertex. Graph dot new vertex property. This is going to be, I think I can do it like that. String. Yeah, how did, oh yeah, okay. New vertex property. And then that's the, okay. So I can actually say, right here, I can say graph object.op for the molvert is equal to that. So I know this is horribly inefficient, but it's I mean, maybe I should just create my own graphing library or something. Not graphing library, but just like, you know, graphing set of whatevers. Also, I just realized. Okay. This is starting to take shape. So I do actually want to set the thing for the graph object.op output row call is equal to plus. Okay, all right. I think that this actually makes sense, and I don't. Yeah, I just want to return the output. I want to return as a graph matrix, so then I can continue doing operations on it. Okay, so yeah, I'm just gonna assume that, you know, no one's stupid. I think I can continue this. I can do something very, very similar here. Okay, so it's gonna be, yeah, all right. I can just say self.dims. I don't need a moldict. And I can set that, but I need to do graph object .graph.add edge, and the source should be self row call, and then the sink should be, oh yeah, I'm gonna mark this as R. Oh, and the sink is going to be output row call. And okay, this is going to be R, and that's going to be the output. Wow, okay, that is surprisingly simple. Now let's make a thing for Hadamard. Yeah, it's literally going to be the same. Yeah, no, it's times. Okay. Yeah, it's literally the same thing, but it's times. All right, I got a decent amount of operations. Okay, so now I need, so we have this computation graph, right? But how do I actually like, yeah. How do I actually like compute anything? Yeah, I built this graph. Now how do I use it to compute stuff? Um, that's a good question. Well, I'm gonna get some water really quick. Think about that. So, yeah, like I need a way. I need a way to substitute the the things for the actual values, and then like run them through the thing. So, yeah. All right. I think I can get rid of this now. Well, I'll keep it around for a moment. I know. It's almost like, yeah, I need a way of substituting. So the thing that remains consistent is the graph, right? Through all of these operations, the graph is omnipresent. So I need to take that graph. Oh, I need to take that graph and I need to do something with it. I need to. Oof. Like, I want to say take the graph and like just like start assigning values to it. I don't know. Yeah, I mean, I guess I can certainly try something like that. Um. Oh, yeah. Reduce, right? Wait, what is reduce? What the hell? What is reduce? There's just a Python thing for reduce? And what is reduce supposed to be for, though? Um. Yeah, I have no idea. I'm not gonna use reduce though. It sounds like that has like a real meaning. So, yeah. Da, 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 da. get out edges of the operation. So I want to get the out edges of the operation. So something that I haven't really considered is how does like the whole thing actually work? Oh. Something I haven't considered is how. Well, I guess reducing would be specifically be like getting a thing, right? Oh no, this should be a float. Ah. Wait, I got it. Hell yeah. Okay, I don't understand. Get out edges. Vert. Virt. Get out the edges. Virt. Oh. This is so hard. What does this mean? Method. Oh, okay. Yeah. I'm gonna do some soul searching. So let's say that I have a graph which looks kind of like this. So I don't know this value yet. So I only know these values. I know that like this is like plus, let's say that's minus. This is times. And I don't know, let's make some variations of this graph. Let's say this is times, and we can even make this times. This is plus. So in this case, A, B, C, D, A plus B times C, D. So A, C, D. Oh, crap. C minus D. Okay, so we know B and C and D, so we will have to do AC times D. We'll probably have to do A plus B times, no, wait. A, C minus D plus BC minus D. So I don't think we've actually like saved ourselves any work by doing this. If we do A C minus yeah. So okay, so this is 1 plus and 1 multiplication that we'll need to do at the end. Right? This is 1 multiplication and 1 addition that we'll need to do at the end. Yeah, so we haven't actually saved any work. Let's look at this now. So we have AB plus CD. In this case, we can do, well, in this case, we'll have to do one addition and 1 multiplication. Okay. Yeah, and there isn't a way to actually like expand this or anything. That's actually why I wanted to look at this one. Yeah, because there's no way. Like, you can simplify this, so that's something you don't have to do, but you still have to do this multiplication and this addition. So, yeah. I don't know. What if we have something that's more like advanced, you know? I don't know. Let's say that this is like F. This is plus. This is also F. Minus times plus. And then, you know, A, B, C, and D. Okay, so we have F of A. F of A minus B. We have, let's call this F. Let's call this F1, F2, F3. Okay, so we have F1 equals A minus B, F2 equals equals A, B, C, D. F3 is equal to CD. Okay, so we have this value, which is, oh no, F3 is not, it's C plus D. Okay, so which is equal to okay, so again with the same story, I don't know A. Oh wow, so I actually can. Yeah, and what's really interesting is that I can actually simplify that further. And I can say negative B plus C plus D plus B, C, D. And then I only have to do 1 multiplication. Wow, okay, so that simplifies it a ton. And this isn't even like that crazy of an example. Like, I have no idea if you would ever do this computation, but you could probably do computations very similar to this. And then what about the last one? So the last value is c plus d. Or no. The last value is just f of c plus d. And so that's f of c plus d, which, yeah, we already know this. So we would have to do f. Yeah, okay. So the outstanding operations are f and are a subtraction and then f, a multiplication. So yeah, it's just sub mul and f are the outstanding operations that we can't do because we don't know a, right? We know all the other ones, and so we can actually compute a lot. So here's a question: how can I actually figure out, right? If I have an arbitrary set of things that follow, like various rules, distributive, associative, etc. How can I determine like the simplest set of operations? Yeah. Can I actually simplify it? So it's clear to me that the simplest thing. In fact, I wonder if I can see this by like rewriting the graph. Because it's clear to me that like, yeah, that doing okay, so specifically for this middle value, right? We do we can say c minus d or c minus b. Oh wait, okay, so we have BCD. Oh, that's my alarm telling me something. Well, the stream is almost over, but I still want to finish this just really quick. Okay, so I see that the simplest way to do this, or a simpler way to do this, a way that's like independent of A, that requires the least input from A, specifically for this middle value, is I compute BCD first. So I compute this times, and then I add it so we can just say this is plus. Yeah, you know what? I'm just kind of annoyed by minus, so I'm just gonna go and turn that to plus because I don't think it actually makes any substantial difference. So then we have BCD. Okay, then we have that. Oh yeah, okay, so that's plus. Okay. And then that is times. Now how does this relate to this graph? Yeah, let's try just like redrawing this graph in a bit more. Yeah, so, okay. This is, plus? No, this is times. This is plus. This is plus. This is plus. So, oh, okay. One of the things that I can do is I can immediately circumvent those nodes. So I can get rid of these plus nodes, right? Because we know that those actually simplify. Oh, so I've gotten rid of the plus nodes, right? So then what happens once I get rid of the plus nodes? Well, I see that we have this kind of structure, right? We have AX plus A. Also, did I actually do that right? Oh my gosh. Oh, I didn't do that right. Oh, that's so embarrassing. Wait, wow, I'm such an idiot. Okay, let's actually do this correctly then. Oh my god. Okay, so then this graph is fake. Fake news graph. This graph is technically fine, but yeah, I messed up. Okay. So it's plus A plus B plus C plus D plus A, B, C, D. I can't really. I can do A1 plus B, C, D plus B plus C plus D plus D. I can't actually. Okay. So the actual outstanding operation. All right, and then yeah, I know I can treat that as one operation. So plus. So the actual outstanding operation is not what I thought it was. And in fact. The actual outstanding operation is we have a add. We have an add. Okay, so we have a multiplication, an add, and we have an add. We have an add and an F. So the outstanding operations are those, which isn't too bad. You know, that's still not that bad, even though I messed it up. Yeah, and this is still simpler, I think. Yeah, because it's went from it's went from an add and right, because I would have had to do add mol add and mol, and as opposed to mol and add, I would have had to do BCD Oh, I would have had to do 2 adds and 1 multiply. But now I'm just doing one add and one multiply, which isn't too bad. Okay. Wait, okay, so that actually is kind of interesting though. So I'm gonna get rid of this because I think that this is weird. All right, so yeah, what does the ideal graph look like now? Right? So even with this, what does it look like? Well, it looks like we have a constant here, and then we have BCD multiplied together. And then we have BCD added together. Oh, crap. So we have BCD multiplied together, BCD added together. And then we have A. Okay, and this is just number 1. Okay, so we have 1 that goes here. So that's an add. Then we have A, which goes into that as well. No. We have a multiplication. Which goes here. Then finally we have an add, which yeah, okay, and then this is F2. Well, no. I don't know what it is, but that's the resulting node. Yeah, so something really strange happened to the structure. Really, really strange. What's more is that we have C and D. Well, yeah, okay. We still need an intermediate value, right? So we still want C and D. Yeah. I'll examine this some more tomorrow. I think I'm definitely onto something with this, but yeah, because I need to think about how I can simplify the graph for unknowns, basically. But yeah, I mean that was basically it for tonight.